Good morning, everyone. So, welcome to my YouTube channel, Avatarm. Today, we are going to see problem Set-VII on uniform convergence of system. Still, if you have not subscribed my YouTube channel, subscribe it for such type of problem sets. Okay. So, we will see. So, let's start today's session now. Few of questions in this problem set already done during the when I delivered the lecture. Nevertheless, these questions are important and they have significance for competitive exams. So we will do it again here, okay? Because this is a problem set. So what is this? Question number 1: A and B belongs to real number set. A is strictly less than B. Which f and B is sequence of Riemann integral function converging uniformly to f on closed interval AB. Put f and x integration a to x f and x dx and fx is equal to a to x fx dx for each x belongs to AB. Which of the following statement is correct? Okay. So let's see this question. Option number 1 is given fn converging to f pointwise but not uniformly on AB. Fn converging to f uniformly on AB. Fn do not converge to f pointwise on AB. Fn, no, option number 4, Fn do not converge f uniformly on AB. Okay. Now let's see its solution. Fn converging to f uniformly. Okay. Each Fn is Riemann integrable. So it converges uniformly on closed interval AB. We know that if each Fn is Riemann integrable, the uniform limit is also Riemann integrable. Okay. On AB. Okay. So once a function is Riemann integrable on closed interval, you take in between point x. Okay. This implies f is also Riemann integrable on closed interval ax, because it is a Riemann integrable on bigger interval. So it will be Riemann integrable on smaller interval. Okay. Similarly, each Fn is Riemann integrable on AB, closed interval AB. So this implies each Fn is Riemann integrable on AX. Okay. On a smaller interval. That is by putting Fn x is equal to a to x Fn dx and fx is equal to a to x fx dx makes sense. Okay. Because these functions are Riemann integrable a to x and a to x fx. So that is why these two functions make sense. These two functions defined. That is why they are well defined. Okay. Now we have to show whether we will show that Fn converging to F uniformly. Okay. So let x greater than 0. Sorry, epsilon greater than 0. Since Fn converging to F uniformly. Okay. There exists capital N belongs to N such that such that fn x minus fx less than epsilon by 2 upon b minus a for all n greater than capital N and x belongs to closed interval a b. Okay. Okay. So it means what? It means also have fn x, fn y minus f y less than epsilon 2 upon b minus a for all. Okay. N greater than equal to n and y belongs to a minus x for fixed x. Okay. We have this one. We have, let's say this equation number 1. Now, what is fn x minus fx? What is this? A to x fn x dx minus a to x fx dx. So what is this? A to x fn x minus fx dx, that is less than a to x fn x minus fx dx. Okay. I can also write it as a to y, sorry, a to x fn y minus fy dy. So from 1, we have, what we have? This will be a to x epsilon upon 2b minus a dy. Okay. What is this? This is equal to epsilon upon 2b minus a. It will be x minus a. Okay. So epsilon upon 2b minus a. If I put b here, it will be increased. It will be cancelled out. So what we have? We have fn x minus fx less than equal to epsilon by 2 for all n greater than capital N and x belongs to closed interval a b. But this is epsilon by 2 is still less than epsilon. So what we have? fn x minus fx less than epsilon for all n greater than capital N and x belongs to AB. What does it mean? It means fn converging to f uniformly on AB. So which option is correct? Second option is correct. fn converges to f pointwise but not OP. First option is not correct. Third option is fn do not converge to f pointwise. It is not correct. D option, fn do not converge uniformly on AB. It is not correct. So option number 3 is correct. Okay. Now see this. Let a greater than 0 and fx is equal to mod x be defined on closed interval minus a point. Then option number A. There does not exist any sequence of polynomial Pn such that Pn converges to f uniformly on closed interval minus a to a. Second is there does not exist any sequence of polynomial Pn such that Pn converging to F uniformly on minus A to A and Pn 0. Okay, for each n. Option number 3, there exists a sequence of polynomial Pn such that Pn converging to F uniformly and Pn 0 at 0 is 0. Option number 4 is for any sequence of polynomial Pn such that Pn converging to F uniformly on AB, Pn 0 is not equal to 0. So let's see this question. So fx is equal to mod x is continuous on minus A to A because mod x is continuous function. And this is closed interval by Weierstrass approximation theorem. There exists Qn sequence of polynomials such that Qn converging to F uniformly on closed interval minus A to A. Okay. Okay. So put Pn x is equal to Qn x minus Q and 0. Okay. Because Qnx is polynomial and this is constant, this implies Pnx it is sequence of polynomials. Okay. And what is Pn at 0? Pn at 0 is Qn 0 minus Qn 0. It will be cancelled out and 0. It means Pn at 0 is 0. Okay. Pn at 0 is 0. Now, since okay. Now, also observe that Qn at 0 because it is converting uniformly to F, mod x, so it will converge to 0, that is fx, that is 0. Okay, it means Qn converging to 0. Okay, because Qn 0 will convert to mod 0. Mod 0 value is 0. Okay. Now, since Qn converging to F uniformly on minus A to A, okay, given epsilon greater than 0, there exists, okay, n1 belongs to n such that 2nx minus fx is less than epsilon by 2 for all n1, n greater than capital N1 and x belongs to minus A to A. Let's say this is equation number 1. Okay. Now, Qn 0 tends to 0. There exists capital N belongs to N2, N2 belongs to capital N, such that Qn 0 minus this is less than epsilon by 2 for all n greater than capital N2. Okay. Now put capital N is equal to maximum of N1, N2. Okay. Then then p and x minus fx. You put the value of p and x, that is q and x minus 2 and 0 minus fx. Now I can write this q and x minus fx plus 2 and 0. But this is less than epsilon by 2 and this is also epsilon by 2. But we are taking maximum, then it will be for all n greater than, and x belongs to minus a to a. Okay. That is epsilon. What is the meaning of this? P and x minus fx less than epsilon for all n greater than capital N, and x belongs to minus a to a. So it means Pn converging to f uniformly okay. Pn's are polynomials with Pn at 0 is 0 for all n belongs to n. Okay. So which option is correct? Let's see. There exists a sequence of polynomials such that Pn converges uniformly and Pn at 0 is 0. This is not correct because we have Pn. While fifth class approximation, it will directly have. There does not exist any sequence Pn such uniformly, and it has, we have checked. So option number B is not correct. Option number 4 is for any sequence Pn converging uniformly. We do not have this. This is not correct because we have found such polynomials. Okay. Okay. Now see this example. Sorry, question. Let AB belongs to R such that A is still less than B and F AB to RB contains functions satisfying this. Which of the following options determine? Okay. F is 0, F is 1 function identical equal to 1, Fx is equal to x, Fx is equal to x square. Okay. Okay. For any polynomial, Px is equal to a naught x to the power m plus a1 x to the power m minus 1. M minus x plus am. For this polynomial, what we have? Integral a to b px fx dx. What you will have? This constant will come out am minus 1 a to b x fx dx. Okay. Plus am a to b fx dx. I can write x power 0 here because it's 1. This part is 0. This part is 0. This part is also 0. It is given in question. This part is also 0. Because it is given in question that integral a b to b x to the power n fx dx 0 for each n belongs to, you take n is equal to 0, you find a to b f x dx 0. N is equal to 1, you will find a to b x f x dx 0. Then x square f x dx 0 integral, like that, okay? For any natural number and 0. So this is 0. A to b bx fx dx is 0 for any polynomial. Okay. Since f is continuous on a b closed interval by Weierstrass approximation theorem, there exists Pn sequence of polynomials such that Pn converges into F uniformly on AB. Okay. Now Pn converging to F uniformly on AB. Okay. So this implies Pn into F converging to F square. That is F into F uniformly. Multiplying both the side by F, it will also converge uniformly on AB. Okay. Now this function Pn is polynomial Riemann integrable. F is also Riemann. Product of two Riemann integrable is Riemann integrable. So this is Riemann integrable. Because this convergence is uniformly, so it will also Riemann integrable. But since F is also continuous, by that fact it is also Riemann integrable. No problem. Okay. So we have limit n tending to infinity a to b Pn f dx is equal to a to b f square x dx. But we have already verified, let's say the equation number, that you take any polynomial, its px into fx integration, which is always 0. Okay. So what does it mean? It means by equation number 1 we have, this is 0 actually. This is 0 limit and tending to infinity, which is equal to, we are taking limit of 0, a to b f square x dx. So limit of the 0 sequence is 0. Okay. Okay. Now you see that f square x is fx ka square. That is non-negative. And f square is continuous because f is continuous. When you have a non-negative continuous function whose integral is 0 on a closed interval or open interval, a less than b, then this is going to be, this implies f square going to be 0. F square is going to be 0. That function has to be 0. If you have an integration of a continuous function, non-negative function, integration of continuous and non-negative function, integral is 0, then that function has to be 0. It means f square x is 0. So it means both f x square. It means f x is 0 or x belongs to AB. It means f is equal to identically 0. So which option is correct? So option number 1 is correct. Okay. Option number 1 is correct. Now move to next question. Okay. This series is not point-wise convergent. This series is uniformly convergent. And third option is not uniformly convergent. None of the above. Let's see this. Okay. Summation n goes to 1 to infinity cos nx upon log n plus 1. Okay. Now, you take this a n x, that is log n plus 1, 1 upon n plus 1. Log n plus 1. So this is tending to 0 as n tending to, and do not depend on x. Okay, on x. Now, each fn is monotonically for fixed x. This is monotonically increasing, goes monotonically decreasing, and it is converging uniformly. An is converging uniformly to 0. Okay, and a and x are monotonically decreasing. Monotonically decreasing. It means they are monotone for each fixed x. Okay. Now what about this? Summation n goes to 1 to k cos n x. What is this? What is cos n x? This summation is I have done this. One minute. This summation is always equal to cos n plus 1 by 2 x. Okay. Sin nx by 2 upon sin x by 2. Okay. So it will take mod cos nx mod, because these functions are bounded by 1, so it will be bounded by 1. So 1 upon 1 sin x by 2. So that is cos x by 2. Okay. But where x is varying, where x varies, x varying from 4 of x belongs to theta 1, theta 2. Okay. So I can take maximum. So this is less than maximum of cosec theta 1 by 2, cosec theta 2 by 2. Okay. Okay. This implies cos nx. Okay. This sequence is uniformly bounded on theta 1 and theta 2. Okay, you can take any K and N belongs to N. K belongs to N. Okay. K belongs to N. So this is uniformly bounded. Now by Dirichlet's theorem for uniform convergence. Now by Dirichlet's theorem for uniform convergence, we have this series n goes to 1 to infinity cos nx on log n plus 1 converges uniformly on this theta 1 theta 2. So which option is correct? Let's see. Option number B is correct. Okay. Option number 1 is not correct, not pointwise converge, because this is uniformly, it will also converge pointwise. Option number C is not uniformly converge, it is uniformly. None of the above, it is already exist. So last question we are dealing. Fn x is equal to e to the power minus n x square is given for x belongs to R. If x is 0, then what is Fn 0? Put 0 here, so it will be 1. So it will change to 1 F0. If x is not 0, then what about minus n x square? Because x square will be positive, it will change minus infinity as n tending to infinity. So what will Fn x e to the power minus x square, where it will converge? 0. E to the power minus x is 0. So what is Fx? Fx is 1 if x is equal to 0. 0 if x is not equal to 0. Okay. So Fn converges to F pointwise. Okay. Now pointwise. Now each Fn is continuous. Each converges pointwise on R. Each Fn is continuous on R. But F is not continuous on R. F is not continuous because it is not continuous at 0. Okay. So this implies Fn cannot converge to F uniformly because uniform limit of continuous function is continuous, but F is not continuous. So this implies F do not converge to F uniformly on F. Okay. So which option is correct? It converges pointwise but not uniformly. So which option is correct? First option is not correct because it converges pointwise. Fn converges uniformly. That is also correct. Okay. Fn converges, so this is correct. Fn converges pointwise but not uniformly. This is not correct. Neither Fn converges pointwise nor uniformly. This is not correct. So option number B is correct. So this problem set is completed. If you have any problem or issue related to this problem set, you can comment me on my YouTube channel. Okay, like, share, comment and subscribe my YouTube channel. Thank you very much for today's session. Thank you very much. We will see you in next session. Thank you very much for today's session. Thank you very much.